Hi, everyone, and welcome to the MLOps podcast. I am Dean, your host, and today I have with me David Marx. David is a distinguished engineer at Stability AI, where he has a lead role in building the Stable Diffusion Inference API, as well as leading the Animation Lab research group. He's an independent researcher affiliated with Eleuther AI, the creator of Python text-to-image toolkit, aka PyTTI tools, a framework for AI art generation. He was previously a data scientist at both Microsoft and Amazon, and a really awesome human being. So, David, thank you for joining us.
Yeah, it's my pleasure. Thanks for having me.
So, as I mentioned to you before we started recording, I feel like since the last time we spoke up to now, the work that you've done has become even more famous. And probably everyone knows about it, but just in case one of our listeners has been living in a cave, can you share what Stability AI is and more about what you do there?
Yeah, absolutely. So Stability AI was created by our founder, Mad Mustak, essentially as kind of a counterpoint to the AI research and product work that's coming out of industry. A lot of the the innovations that seem to have the most potential to do a lot of good in the world are only really able to be built by groups that have really significant resources. And as a consequence, a lot of that work was happening out of labs like Microsoft and Facebook. And Ahmad is this really generous guy who's independently wealthy and decided to just start pumping money into open source machine learning. And the idea is that we're a group of researchers largely and developers who want to democratize the benefits of machine learning and AI and make the tools and things that are going to be, kind of changing the world accessible to people. If that,
yeah. Yeah, that makes sense. I think that the fact that today, I was visiting my grandmother, who's 95, a few days ago, and I was telling her a bit about the work that I'm doing and a bunch of interesting things that are happening in the world of AI and machine learning, and of course the sort of whole concept of generative models came up, and I could sit with her, like, she's 95 years old, and I could use sort of the Dream Studio and tell her, like, give me a prompt and show her that a computer can basically paint something that she suggested in basically a few seconds. I think that's pretty incredible in many different ways. And I guess I'm also curious, like, about your specific angle. So how did you get to the point where you're working on this, and how do you get into machine learning in general?
Yeah. Very, very good question. So I've had kind of a funny route in life. Also, I need to comment. I think it's great that your grandma gets to see this stuff. My dad's turning 80 in a few weeks, and he doesn't get it at all. My parents don't understand what I do. It's so funny. They're like, "Sure, okay, computers." But yeah, I actually started. I got my undergrad in philosophy. So I had kind of an unusual route, which is actually pretty common at Stability. A lot of people come from unconventional backgrounds for machine learning and engineering. So maybe that's not as unconventional as it used to be. But yeah, I did my undergrad in philosophy, kind of with a focus on philosophy of mind. So from that, at least, it's a very corner of philosophy that's amenable to the work that I'm doing now. And growing up, I was always like the math kid in high school and went to like nerd camp. Like literally, I took my first like formal real CS course was seventh grade summer camp thing. I took CS for fun. So I even like was like a volunteer firefighter for like about a decade. And
Wow.
through that experience, I ended up realizing I actually wasn't into patient care at all, which was, you know, an unfortunate thing to figure out shortly before taking the MCATs. And yeah, so I had always been interested in computers and programming, but I'd only ever really considered it as like a hobby. It just it hadn't even like occurred to me that it was something that I could pursue like professionally.
Mm-hmm.
And a couple years after college, I kind of fell into a developer role through a company that I started out as a temp. They were like, oh, hey, this kid has a lot of really like analytical skills. I was temping there, and like my first day, I added some Excel wizardry to their spreadsheet that like knocked out like a whole column of this data entry project that we were doing. But in any event,
I feel like a lot of people have a similar story in the sense that like if they didn't get into programming in a, let's say, like classical approach of like you study it, then you apply for jobs and you get into a developer role, it's somehow always related to like automating Excel, like Access, stuff like that. That's it's interesting. I have a few friends that have sort of a similar story. They just got into a place, they needed to do something related to the data, and they realized like if I write code, it's going to take me a tenth of the time, so I might as well learn how to do this. Or if they knew, I might as well just do this. And then that was their break. So that's interesting. But yeah, continue. Sorry.
100%. I remember one of my first little presentations that I gave when I was new at Microsoft. I think I was talking about best practices to my team, and I articulated what we're describing now in a way that I think was concerning to my managers then, which was something like, good developers should be lazy. You should be really, really lazy. We are fundamentally lazy people. We want to do as little work as possible. We want to automate everything.
It's true. It's true.
Right. But yeah, I fully agree. I definitely got a lot of my early exposure to coding and stuff through a desire to make my own life easier. Just kind of being like, this is something that I'm doing that's repetitive. There has to be an easier way. And that ideology ended up leading to a project where, so this company that I was at is this thing called Sound Exchange, which deals with music royalties. And they essentially had an issue where money was coming in for songs, but the people who the money was for weren't getting it for a variety of reasons. And so I was involved in these matching exercises, and they were very manual at the time, just, you know, like writing out SQL queries by hand with like wild cards and stuff. And I was like, there has to be an easier way to do this. And that led me down the path towards natural language processing and information retrieval and learning about text similarity. And from there, the Pandora's box of machine learning just kind of flew open for me. And that was around 2010, 2011-ish, I think.
Oh, wow. So very early.
Yeah, I am very fortunate that I have kind of been evolving my career, like just riding the deep learning wave. It's been very weird. But yeah, I was in the like inaugural Andrew Ng Coursera course back when it was ml-course.com or .org or whatever it was. And that was, you know, essentially like a life-changing like experience. Thank you, Andrew.
Did you get a chance to meet him since, or?
I have not. Concretely.
I'll add mention him. I'll add mention him in this when we post this episode. So maybe you'll want to reach
But yeah, Andrew Ng's Coursera course and all of the early Coursera stuff was extremely helpful. And I found that I was increasingly like throwing all of my time and energy into meetups and reading like tutorials and stuff online, and like you can see behind me, like just like buying textbooks for fun. And eventually I was like, okay, I should probably put some more structure around this. And so what I should do is I should follow a curriculum, right? But instead of like actually taking a course, I was like, I'm going to go and see what courses are around me and go check out like the university websites and see what textbooks they're using. And I'm going to go to the university bookstore and thumb through the textbooks and see if the textbook looks like it's something I want to read. That was my plan originally. I just wanted to go to the university bookstore. And that led me to, I was in DC at the time. So I was poking around the University of Georgetown website, and I was looking at their math stats program. And I was like, oh, that course looks cool. That course looks cool. All of these courses look pretty cool. Shit, should I go to grad school? So I ended up applying to that program like a month before applications closed. It was the only program I applied to. I understood that I had an unusual background for the program, because I had mathematical ability and had taken a lot of math when I was younger, but I took 2 semesters freshman year of college and full stop. I basically got through Calculus 3 and was so I struggled so much in Calculus 3. Like I passed, but it was such a struggle that I remember thinking, I've plateaued. This must be what everyone else around me who has struggled with math the rest of my life feels like. I finally understand. I think this is as far as I've gotten, because I thought math was this linear thing, which it absolutely is not. So I reached out to the head of the program and was like, hey, this is what my application is going to look like. Do you have any like recommendations for me? And they were super helpful. They like made recommendations to me for things that were really easy and small for me to do, but that I just would not have thought of, and like impacted their internal scoring system. So if anyone has an unconventional background who's thinking of applying to grad school, I strongly encourage you to just reach out to the program that you're thinking of applying to and just be really transparent about what your application is going to look like, and say, hey, what do you think are my biggest weaknesses? How can I strengthen my application? They're there to help. But in any event, I was very fortunate and got into that program, and I had a great time. It was an extremely beneficial experience for me. Really strengthened my foundational understanding of like probability and statistics and things, which is immensely useful in this field. And was essentially snatched up right out of grad school into a data science consulting firm. So one of the adjunct professors there had a firm, or was the head of the local office for a group called Elder Research. So I worked at Elder Research for 3 years, I think, doing data science consulting in the DC area. So I worked with a whole range of things. I did stuff for like Fannie Mae, Department of Labor, OIG, 20th Century Fox, all over the place.
Nice.
So that was really interesting and gave me exposure to a whole range of machine learning problems. So we were doing stuff that was, kind of more conventional regression prediction type stuff, a good deal of fraud detection, sprinkling of graph analytics here and there, a bunch of NLP. So it was really interesting getting to have that exposure to a wide diversity of problems. I remember after grad school, originally at first being kind of like not jealous exactly, but like seeing friends who had gotten their jobs at companies that I'd heard of, you know, and being like, oh wow, that sounds really cool, and then like talking to them afterwards and being like, yeah, it's a cool place and I like the problem that I'm working on, but it's very narrow and I'm just doing the same thing all the time. Like all I do is optimize for this one parameter, and that's all that like my job is. And it's like, okay, well, my job isn't always interesting, but I get a lot more diversity than that. So that was cool. And yeah, after a couple of years of that, I was in the market for something new, and Amazon reached out to me through a recruiter, like they do, and they enticed me to come out to Seattle. So I moved from one Washington to the other, and started working in Amazon's TRMS organization. That's a transaction risk management systems. So that was more fraud detection work, and did that for about a year. I remember my elevator pitch back when I was at Elder Research, and then, you know, at the beginning of Amazon, was, I fight crime with math. And then I realized a couple of months into my Amazon gig that actually success in my role was measured through how much I could reduce headcount, because I was actually a data scientist supporting the operations group there. And so it was literally like, how much can I automate away at human labor? And so my elevator pitch went from fighting crime with math to, hey, you've been reading about how AI is coming for your jobs? David Marx is coming for your jobs. I am the machine learning that is going to automate you away. So that was way less sexy and a bit more stressful, and Amazon just wasn't for me.
Fair enough.
Yeah. So after a year at Amazon, I kind of mic drop quit. Could have been more political about that, but just kind of came in and was like, peace. And then traveled for a month before starting a new role at Microsoft. And Microsoft, I worked in a group called Worldwide Learning. And the mission was more aligned with my values. It was a group that owns their, like a lot of their educational products, like the certifications and things. So it was, you know, doing data science and analytics kind of to like support people's, you know, growth in their professional careers. But what I ended up learning from that experience was that I have kind of developed a little bit of a little pessimism, I guess, about roles that are marketed towards data scientists today. I ended up finding in that role that a lot of the work that we were doing was capturing what I would call low-hanging fruit. And as I was in that role and frustrated with the work that I was doing, because I didn't consider it to be like challenging enough in the or a lot the kind of work that I wanted to be doing, I remember looking at data science job postings and stuff, and actually like characterizing skills from job postings was a big part of my role there. And I essentially came to the conclusion that the term data scientist has evolved a fair amount, and what data scientist was used to characterize, what that role characterized kind of like before I was starting grad school, nowadays I think is closer to what people would call a research engineer. And the role today, data scientist, is more what used to be called data analyst. What I have found is that a lot of the data scientist roles are supporting organizations that are going through some kind of transformation to be more data driven. And really what I was looking for was a role in an organization that kind of was already more data driven and was prepared to kind of have someone, do analytics. So, excuse me, get a little water.
No worries. It's interesting. It really seems like sort of it seems like there are two constants in the way that you describe your path, and I'll let you continue in a moment. One is the value aspect, and the other is like the challenge aspect. I think that a lot of people share those like criteria. Obviously, it's different for everyone, but I find it interesting. It seems like in your Microsoft job, you basically did like a meta research also for yourself into how to analyze skills for positions, so you knew maybe how to find things that were more suitable for you. Is that correct?
To some extent, I had the data and the tools available for me to do that, and could have done that a lot more than I did, but I didn't actually. I really should have. When I was at Amazon, I actually did that a little bit more. I remember, I don't remember why I had access to this data at Amazon. I think it was just at Amazon, like everything kind of lived in the same data lake. And if you had access to like some threshold of data security, you had access to like a whole bunch of stuff. But one of the things that I had access to, I think this was at Amazon, was people's like organizational histories. And so I could see, oh, hey, if you are a researcher in this department, what was your trajectory through the organization? How did you get there? And so I started kind of like hunting for researchers that had like, like didn't have PhDs and stuff. And I was like, okay, how did you get to that role? How did that happen? So I definitely did do a little bit of meta research in that way. And that was helpful, at the very least, to find departments that looked interesting within Amazon when I was there. But yeah, the work that I was doing at Microsoft was much more like, okay, we want to know if such and such role, like trying to characterize what the skill sets were for a particular role to kind of design, the educational material around it.
Yeah.
But yeah, I definitely could have used it for my own personal research more, but
development. Yeah.
But yeah, so regarding like, challenge and all that being a theme, I think a big part of it is just that I like struggle with adult ADHD, and so I part of why I look for challenge is just because I'm like, ooh, shiny thing over here. Like I have trouble focusing on the same thing for more than 3 to 6 months, which I think is common with a lot of researchers.
Fair enough.
Maybe not. Maybe not. I don't know. We can cut out that part.
I'll mark it. I think that there's. I think I've mentioned this in another episode as well. But like part of the reason I was drawn to entrepreneurship is because of the fact that you have 5 days of a week, you work on at least 5 different problems that are very, very different from one another. And to me, like I didn't have that in other places. And I feel like that diversity of challenges is something that can keep you going for a long time. But if you're working, and I think this also alludes to what you were saying earlier about large organizations, like if you're working on a really hard problem, but it's really, really narrow, then that's going to me to be less interesting. And I feel like there's maybe another type of person who prefers to have a really narrow but very deep problem. They want to bang their head against that, and that's also fine. And I feel like when I was originally thinking about these things, I thought that like actually a researcher is the second type. Like you go really deep on a problem and you only focus on that and everything. But I think today, it's also 2 different types of researchers. Like there is one researcher who's like, the classic, I don't know, the math professor from the movies who has like an equation they need to solve or prove or something like that. But there are also people who are like trying to do something which is more applicative. And I think in machine learning, that's much more relevant, where you're just trying to find ways to apply something that is very complex and very, very cutting edge to a bunch of different use cases. And you see that with a large research industry research labs, but also I think in academic groups where they just, try different things. And I feel like that's probably a lot of what you're doing today, if I may venture a guess.
Yeah, no, you're 100% correct. And I always feel a little funny characterizing myself as a researcher. Like the imposter syndrome is extra real when you have like 0 citations. So a lot of my work involves just kind of like treating other people's work as Lego bricks and just kind of figuring out what I can kind of mix and match and trying to just kind of demonstrate what's possible and what's capable. So like, for example, one of my projects recently was putting out this notebook that demonstrates a way that you can just kind of from a video URL, just take that, drop that into the notebook, and it'll just generate a fully edited music video for you based on, and it's like, it's clever, but it's a sleight of hand because all it's doing is performing automated speech recognition on the lyrics and then using that process to also segment the lyrics into prompts and then passing that through Stable Diffusion and then doing a little trickery to kind of animate the scene. So it's like, there's nothing really novel there. It's just a couple of like pieces strung together in a way that's interesting. So that's the kind of stuff that I usually end up playing with. I find I used to think that I really wanted to train models, and I still do enjoy that, but I just don't have the patience to optimize the thing. So I'll get it working and be like, okay, good enough, move on to the next thing, which is actually a very powerful instinct in industry, less so when you're trying to do research and you actually want to, you care more about the performance than just kind of having something that's good enough. But
yeah, it's product thinking, right? Like you want to get an MVP, like something that is valuable, but also minimal so that you can ship it out to users and iterate after you get feedback, which is a much more powerful process because you're not iterating for the sake of iteration, but because someone actually is bothered by something that isn't working or that isn't working well enough. And then improving performance is important. But until you get that feedback, good enough is probably the way to go, at least from a startup perspective, not necessarily a research perspective.
And also I think I mentioned how a lot of the work that I was doing was kind of involved in organizations that were going through kind of data transformations and weren't very mature with respect to data science and analytics. And so it's very easy to hit that good enough mark. So oftentimes I would be working on something and have a kind of naive solution that I would assume would be like the benchmark for something cooler that I would build later. And the benchmark would end up being the solution because it would just be good enough. So yeah, that kind of good enough.
Yeah. I think that's how things should work. If the baseline works, then you should use the baseline and only optimize when that's the top priority, like the thing that would move the needle most. So wait, I want to walk back to the sort of your life story. So you decided that you want to move on from Microsoft, right?
Yeah. So
because I think it's interesting. That's why. So yeah. So
absolutely. So as I mentioned, I play with pre-trained models a lot now and play with other people's training outputs. But I remember an ongoing thing when I was working at Elder Research, when I was at Amazon, when I was at Microsoft. I was like, where are the GPUs? Why am I not even looking at a ROC curve right now? Why am I not training models? And just being frustrated. It's kind of an unusual curse of specialization, I guess. I don't know how else to articulate it. I experienced something similar when I was a firefighter, I mentioned. When I was in that role, I was volunteering at a department that was fairly specialized. It's the group that, like, if you're in a car accident, they're the ones who come with the jaws of life and cut you out of the car. Or if there's a collapsed building, they have all the special tools for that. Like, the truck that I was on was literally a giant toolbox. So it was a very specialized unit. And as a consequence, often we would get called for things and get turned around before we even got there. We had a very specialized set of skills and only got to use those skills very rarely. Most of the time, the things that needed to get done were not, in that kind of specialized context. So something that I think frustrates a lot of people in the machine learning field is they learn all these really cool, interesting, sophisticated techniques, and they only get to use them very rarely. It's like an analogy that I raised recently was like how general practitioners, physicians, will go to medical school for 8 years or something like that and learn tons and tons of medical knowledge to become a family practitioner and, see kids with colds, and see the same thing 3 to 5 times a day. And it's not bad that they go through that training. It's just that they only get to leverage that training on a rare occasion. And when that occasion arises, it's important that they have that training because they're in a minority of people that are equipped to handle that situation and to even recognize it. And I think that's similar in machine learning, where you might have, a group of people in your organization that are kind of using the same traditional modeling techniques over and over again, but every now and then they'll get some kind of really unique situation, have to check for some unusual signal, and then they get to use this sophisticated technique that they've been looking for an excuse to use for 3 years or something, But in any event, I remember kind of feeling that FOMO. As I mentioned, I was, I kind of started grad school right around the time that AlexNet was coming out, right when deep learning was hitting the scene. And I, was in industry reading all these cool research papers and keeping up with everything. And
when it was still possible.
Yeah, back when it was still, oh Jesus, yeah, good call. It's the advice that I give people these days is basically don't even try and catch up. Just figure out what you're interested in, jump in, and keep up. Just don't look back. But yeah, the straw that broke the camel's back was when I finally buckled down, was like, you know what? I'm a professional data scientist. I should just buy my own GPU instead of waiting for an excuse to use one at work. And immediately after I had my hands on a GPU, I was like, this is so much fun. Why have I been putting this off for so long? This is clearly what I want to be spending my time doing. And by that time also the group that I was in had largely dissolved because the organization just wasn't ready for data scientists. They did not need us. So I was like, there's really nothing keeping me here. I kind of recognized in myself that the main reason that I hadn't left already was largely just fear and anxiety over not having health insurance and having been raised by parents who beat into me this idea that it's a lot easier to get a job if you already have one. Don't quit into nothing. Look for a job while you have a job. And so the idea of being unemployed and just kind of just being unemployed and that being the thing that I was doing was just kind of a terrifying idea for me. But I leaned into it and was just like, I'm just wasting my time. I'm wasting your time, later Microsoft. And, jumped ship to revisit all the tools and techniques and research that I had felt like I'd been missing out on, and, focusing on industry. And that was the end of 2021, almost exactly a year ago. And January-ish of 2021, OpenAI released their CLIP model. And CLIP was this model, for your listeners who are unfamiliar, I imagine most are probably familiar. CLIP is this model that takes text and images and puts them into the same representational space, which is extremely powerful for a lot of reasons. And this model ended up sparking kind of a revolution in the AI art scene. It's kind of sparked a revolution in a variety of ways, but one of the revolutions that it sparked was in AI art. And in particular, this guy, I think his name is Ryan something, adverb ad noun, I think is his, I should remember these people's Twitter handles. Anyway,
we'll find him later and add him in the comment. We'll find him, description.
Yeah. He came up with this trick that I think he called the big sleep at the time, which was a way of using CLIP to you could provide text to the classifier, and the classifier gives you a likelihood score. And so you could apply the classifier to some sort of model that is capable of generating an image, and then use that likelihood score as a way to ascend towards an image that is closer to the text that you put in. And so through that process, it was a very simple way that you could just take an out-of-the-box model and slap it onto something, and all of a sudden you put in text and you get an image that's relevant to it. And then I think Catherine Krausen came up with, I think she's the one who came up with the CLIP plus VQGAN technique. And that added a lot of accuracy for a variety of reasons, and made the images even more relevant. And so in the background of my time at Microsoft, there'd been this whole revolution in AI art going on. So after I left Microsoft, among the other things that I jumped into and started playing more with was that stuff. And I got involved with a particular toolkit, this thing called PyTTI, PyTTI, that was developed by Henry Rachutin, I think is his name, Sports Racer 48. And yeah, he had released a couple of versions of this thing, and the last one that I think he really played with was in November of last year. And so I think around December, I reached out to him and was like, or actually he reached out to me because he saw that I was kind of tinkering with it. But in any event, we got in contact with each other, and I was like, hey, can I help you maintain this thing? Can I help you add features? And he was like, oh yeah, do whatever you want. And, I'm not going to I totally support you playing with this. And he basically just kind of shoved the project in my arms, and just kind of he didn't walk away exactly, but his last release was in November, and he just kind of walked off into the sunset. So I took over and, started maintaining the thing and trying to make it more of a tool instead of just a notebook. And I released my project, I think end of February of this year. And that I had already, after leaving Microsoft, one of the things I ended up doing was I also started getting more involved in kind of the open source community more broadly. So I had already been an open source contributor. A lot of my work had revolved around actually Reddit. So there was
everything goes back to Reddit.
Everything goes back to Reddit. I used to say Reddit was my muse when I was first starting with data science, because the Reddit API was so rich. It's just a really fun data source to play with. But there was a project called PushShift, and push shift is essentially an archive of Reddit data. And I had built an API wrapper for it. So a lot of the work that people were doing around Reddit data was using my thing as like an intermediary, PSAW, I think is what it was called.
Okay.
Yeah. Anyway, good old PSAW. Don't use PSAW anymore. I'm not updating it. Use PMAW. But yeah, I'd done a couple of like open source things, but I really started to get more involved in like the community side of it, and I started hanging around the Luther AI Discord, and between and so yeah, also the Luther AI Discord was kind of where a lot of the AI art stuff was happening. Was a big part of what had drawn me there. And yeah, so I think between my involvement with Luther AI and this open source project, when I did like kind of my big PyTTI Tools 1.0 release at the end of February, Imad reached out to me and was like, hey, I see what you're doing. I like the work that you're doing. What do you need to like be able to keep doing this? And I was like, what? And he's like, yeah, I support a lot of people in the machine learning open source scene. And so he kind of gave me a rundown a bunch of the different like people and ways that he supported. It's like, yeah, all those people with like the AI art notebooks, like a lot of them are people that I'm like either, funding or I'm giving compute to. I give compute to a lot of research organizations. I've given compute to a Luther AI to train some of their large language models, helping fund a couple of people through their PhDs. What do you need to be able to like contribute to open source machine learning full time? And I was like, well, a salary and health insurance would really help make me comfortable. And he was like, all right, cool, bet, let's do that. And that was essentially how I got started with Stability. And I had no idea I was going to get kind of pulled into this vortex of, early stage startup. But it's been interesting to say the least. I'm really glad that I'm here and have the opportunities that I have. But I also completely recognize that, a big part of why I have this opportunity is because I grew up with a lot of security. Like I am fortunate that my family had some wealth growing up, and I was able to get an education and just go to grad school on a whim, and had the kind of safety net where I could just quit my job for a few months because I had savings and I had a family that could back me up if my savings ran out. And it's an unusual thing. And I would not have found this opportunity if I hadn't taken that time off. And taking that time off is something that is just not feasible for the vast majority of people. So I recognize that a big part of my success is just that I've been very fortunate, and so.
Luck is important. You can't get anywhere without it. I think it plays a major role for all of us, and I mean, I think it's still, there's a lot of points throughout sort of your journey where I think you followed your curiosity. You worked on things that you felt were important, even if it wasn't clear to other people that they would be. Obviously, just the idea of doing that means that you have sort of some backup that you can take. But I feel like if you can do that, then that is nice guiding principle. Like if you believe something is important and you can invest even some time, not necessarily your full-time job in doing that, that's worth exploration, because you never know how things will play out in the long run. And as you said, like you've sort of been also lucky to ride out this like deep learning wave. But obviously, I think if you'd ask people in 2012, not a lot of them would anticipate that this is how the world will look like in 2022. So even just like being along for the ride, it wasn't clear that it's going to be such a tsunami when it started. So I think that's an amazing story. Thanks for sharing that with everyone. I guess I have two follow-up questions. The first is, what are you sort of working on in the context of stability AI, if you can share? I think that would be really interesting to learn more about.
Yeah, so as I mentioned, I kind of do a lot of work sort of just like stringing together pre-trained models and other people's research. So right now I'm kind of taking a little bit of a breather because the API launch was a thing. It was stressful.
Yeah.
It was stressful. But we managed to pull it off, and we get by with a little help from our friends. So the API team has grown quite a bit, thankfully. But it was about 2 or 3 people when we were really going through the launch, and it was like myself, Tom, who's our CTO, and Chia were really most of the API team internally, until we brought in the Cavalry, who was a bunch of developers from CoreWeave came and helped us out, and they're still a huge help. So big shout out to CoreWeave. Y'all are awesome. And yeah, so the API has been a whole thing, and we are kind of, it's an interesting thing, right? Because Stability is a for-profit organization that is essentially like trying to fund a bunch of like nonprofit research efforts. And the Stable Diffusion API is like the commercial product right now. So there's the API, and there's also Dream Studio, which is the front end. I'm much more involved in the back end than the front end work. There's some stuff coming out with the front end that I think is going to be announced in the very near future, so I won't spoil. We're working on some fun animation stuff. So a lot of, as you mentioned, I kind of I'm the leader of the animation lab, which really just means I am continually advocating that animation research needs to be separate from our product work, and we have a bunch of geniuses internally who need to be able to do some stuff on their own. But yeah, I'm not answering your question. What are we working on? What are we coming out with? Yeah. So what I have been working on is essentially trying to come up with interesting ways to parameterize animation work. And I'm essentially trying to move towards a system that strikes a middle ground between letting users put in a very small amount of input and get a lot of relevant content in return, but also giving them opportunities for control and intervention. So a lot of the kind of the driving animation paradigm behind a lot of kind of the core group that we've been building on our team is what people are now calling image to image. So it's a very sequential process. So you produce an image, and then you transform it somehow to create an initializing state for the next image generating process and rinse and repeat. So it's necessarily very sequential, which is actually kind of, it made a lot of sense back in the VQGAN days and the early diffusion days, but Stable Diffusion is just so fast that it's actually really powerful if we can bulk generate images. So a lot of the stuff that I've been playing with has been ways for people to animate that let you generate images in like parallel, but that also means that the animations are very limited. So it'll be something like you have an init image, and then you just kind of bring that image a little bit to life, but it doesn't actually move very much. So a lot of the stuff that's coming out of the API work, which has really largely been other people since I've been kind of pulling back from the API. So big credit to like Dango and Pharma Psychotic, something like that. I know everyone by their Discord names. I want to say Jim. But they've been doing a lot of the animation work. But it's really more geared towards the image to image type stuff and adding like navigational controls, I guess. So what's kind of interesting about that paradigm is, on the one hand, you have to generate things sequentially, but on the other hand, it's a very generic method. So the way that it works is you, for example, like I think this is actually a technique that actually started in the original PyTTI. You take an image that has been generated by a text-to-image tool, and you use a separate model from what you used to generate it to estimate the depth map in the image. So generate an image, and you throw a depth estimating model at the image to infer a rough depth map. And then you apply a 3D transform based on that depth map. So assuming that the depth map is correct and you want the camera to go through this path in the space, this is the change that you would apply that the image would go through. So, you apply that rotation in the image space, and it gives you kind of a bit of a warp. There's going to be some stuff that doesn't quite work. And then you just give it back to the text to image thing and let it try and fix itself. So it's a very generic process that you can switch parts out of. You can change, the text to image model. You can change kind of what the image prior is. So like you can think of VQGAN as one kind of image prior and diffusion models as another image prior. You can apply customized losses to the gradient of that process, so you can optimize for all sorts of weird stuff. All these classifier guidance processes. So classifier free guidance has been taking over everything now, but I'm still fond of classifier guidance.
Well, I can't wait to try it out when it's out. Probably before this episode will be out, but yeah, I guess another thing that was to me really unique about your story is your involvement. So maybe this goes deeper than your technological pursuits because of like the firefighting and med school and everything. But I think you uniquely spend a lot of time working for or on nonprofits, open source technology, and you've sort of managed to get to the point where you can actually build a career around that. And I think for a lot of people that are listening, that is very appealing. So I'm curious, aside from the things that you already mentioned, like if someone listening wants to sort of go down your path or something similar, how can they do that? Like, what are your recommendations?
Yeah. So you mentioned something kind of related to the advice I'm about to give earlier. One of the best pieces of advice I think I can give is I'll often see people asking on forums and stuff like, what skills should I pursue to be employable? How should I spend my time? What should I study, etc.? The fact is, the field is gigantic. What a data scientist is changes depending on who you're talking to or what the industry is. And really, what you should be trying to figure out is what the work that interests you looks like. And it obviously it's worked particularly well for me. But apart from kind of like the unusual career trajectory I've had, one of the things that's worked really well for me is by investigating time and energy in passion projects. I've essentially necessitated that the skill set that I develop is relevant to the work that I want to be doing and the work that's interesting to me. So I strongly encourage people to try and have some kind of back burner project at any given time, not just as, like a continual education kind of thing, but also as sort of a like a guiding light almost to remind the person of what interests them and what they want to be working on, and to help motivate keeping up with the research in that domain and the tooling in that domain. So a big part of how I have developed the skills that I have has just been through playing with things. And a lot of the skills that I developed playing with things are things that I brought into the workplace. So this isn't to say that you can only be successful if you spend a lot of your own time like out of work studying or whatever. I'm not saying that. More that you should be investing your time and energy in the kinds of things that are interesting. So a lot of so I mentioned passion projects and things. I've also been able to bring this kind of attitude into my work. So I mentioned that one of the first projects that I had that really opened me up to machine learning was motivated by a business problem. That business problem was something that I just kind of invented because I wanted my own life to be easier. So I wasn't tasked specifically with building this whole information retrieval system at work. It ended up like becoming something that they essentially built a department around. I don't get all of the credit for that. My supervisor at the time, Martin Silberger, also, yeah, Martin, all the shout outs. But yeah, when I was first getting started in that role where I was kind of just getting my feet wet with my career, I would find all sorts of excuses to bring things that I was interested in learning more about into kind of the office. And so I would find excuses to learn R, to do data visualization stuff, to make prettier charts that were unnecessarily pretty, but it was fun for me to make them pretty, or playing with Python to figure out how to access some data set that I was like, there has to be a better way that we could do this. And yeah, just whatever, the types of problems that you see in front of you and that are going to be things that you are interested in working on are the kinds of skills that you should be moving towards, is the best advice I think I can give.
I like that. I think that I take continual learning very seriously. I think you should always be exploring and expanding your horizons. And if you're not, even if it doesn't feel like it's bad, it's probably not the optimal use of your time. But I think that the point that you're making is like more subtle than that, which is if you're only learning for the sake of learning, which is again not bad, that means that the chances of you becoming over time less connected to practical things is larger, is greater. Whereas if you have a project, even if you're solving a problem for yourself or an invented problem, but it's like sort of constrained in the real world, then the sub tasks that you're going to give yourself and that you'll need to learn are connected to sort of a larger theme. So that's you're more likely to stay focused on something that actually matters. And I think that that shows both with how you've handled challenges in your professional career, but also how you've chosen to work on personal projects. Like there was sort of a set of very clear issues that you were trying to tackle, even if those issues were, how can I make a better experience for generating images from text? You can build something around that. And that is a problem that you can clearly define to other people, as opposed to, I decided that this topic is interesting, so I'm just learning it for the sake of it. So I like that. I have another question that I'm really interested in on a personal level, which is obviously this podcast is called the MLOps podcast. We speak with a lot of people about a lot of different things, but I'm curious, like when you look at a model like Stable Diffusion, even with all of its advantages compared to other let's say similar models, that it's very fast and it's relatively the resource requirements are relatively low, so even normal people can run it reasonably well. It is a complex model, so I'm curious, like, how does deploying a model like Stable Diffusion to production look like? Especially, given I know that the API launch was sort of rough. I think part of the reason is a lot of users came. So how does that deployment look like when actually a ton of people are using it? I'd love to hear how that looks behind the scenes.
Kubernetes. Another big thing was moving away from Python in certain places. So we let Python own the actual machine learning and inference code, but the application communication and the network layer is all Go. So again, that's the CoreWeave guys. They basically just came in and are like, oh, hey, we've done this before. Here, use our framework here. I was like, yes, please. Thank you so much.
Nice. The DAGs backend is in Go, so I have a soft spot for Go as well, and that makes but you're saying basically that the inference code itself is still Python. Like, you didn't outsource to, I don't know, other frameworks or something like that. It's that's interesting. And so go ahead.
Yeah, it's still Python. It's just PyTorch. So the code is modified from the CompViz Stable Diffusion repository, but the original Stable Diffusion code is all there and available. There's also a Hugging Face release that you can use for inferencing on it, and that's basically like what our backend code looks like as well. It's very similar to all the public code. So essentially, we have actually you can even see our API protobufs are public, but basically we have a front-end API that you can communicate with through a client, and that hits a middleware that handles a bunch of processing logic and delegates jobs to back-end workers, and the workers handle the actual GPU compute. One thing that I think was kind of interesting about our overall infrastructure, as you mentioned, Stable Diffusion is a model that doesn't take up a lot of resources to run, and so that actually has consequences on what like efficient GPUs are. So
Mm-hmm.
a lot of our Ahmad's focus when he was building the research cluster for stability was get all of the GPUs we can, and it was all A100s. And
Yep.
A100s are great for training, but they're kind of like chonky for the inference that we do, because they just have so much memory on them.
Yeah.
And there are I can't remember precisely what GPUs we're using for inference right now, but the cost-effective GPUs for training aren't necessarily the cost-effective GPUs for inference. Is really the message there.
Mm-hmm. So does that mean that you have two separate clusters today, or did you find ways to make the A100s more efficient for the inference?
Yeah, no, we have a separate inference stack. So
Okay.
the whether or not we're doing inference on A100s, like we would probably keep it separated like that anyway, just to have two logical units, so we can
Unit.
kick everybody off of the research cluster, for example, if we want to train one model on everything.
Mm-hmm.
And it's important that we be able to scale our inference stuff up and down.
Yeah. Okay, that's really awesome. I think one of the things that you don't get to see that often is when inference is in any shape or form using a GPU. So were there any counterintuitive challenges with just like inference on GPU versus inference on non-GPU or CPU servers?
Um,
Maybe another way to put this is, if someone listening here is before the hump of doing a first GPU deployment, do you have any advice for them?
mm, um, yeah, I guess the main advice I would say is it's all about memory management. One
Mm-hmm.
of the things that differentiates how we do inference kind of at like our production level versus how you will see inference happen in like a Colab notebook, for example,
Mm-hmm.
is the notebook is all on one compute node, right?
Mm-hmm.
So you have to load all of those models into that node and, either move them back and forth between RAM and the node or whatever.
Mm-hmm.
Whereas when we're doing inference on a distributed compute infrastructure, you can essentially assign, each model to its own node, with
Mm-hmm.
some exceptions. But you want to delegate that kind of communication as much as you can, and you want to try and minimize the spin up time as much as possible.
Mm-hmm.
So we that is actually something that was a big surprise to me, was the amount of concern that we put into how fast we can instantiate and load a model into memory, because that impacts the scaling back pressure. Um,
Yes.
we Once a model is on a worker, you can inference it and you don't need to unload it when the worker is done. So you just
Yeah.
keep that model there and you inference it. But if you need to scale up or scale down, like if you all of a sudden have a big burst in traffic, then
Sure.
if your model takes a couple extra seconds longer to load, that's a couple extra seconds that you're not responding to that burst in traffic. So that is an unusual facet of things that I think that the time component for not just the inference, but even just spinning things up takes a lot longer. I think that really annoys more conventional backend developers too.
Yeah, that makes sense, and I understand like why it would be something that you'd maybe not prepare for in advance, but then invest a ton of time improving, because that affects the user experience in the end. Okay, awesome. Whatever you want, can be additional shout outs. Yeah, go ahead.
Yeah. For data science, one book that I think is really, really valuable and contains a lot of the kinds of like lessons learned that you would normally get through experience, but they're just kind of listed out as like a bunch of like little tips and hints and things, is this book called Guerrilla Analytics. So I am fortunate not to need it these days, but that is a great collection of just kind of general data science, like project structure, like tips. And yeah, I guess the other general advice would be contribute to open source. There's so much benefit, not just to the community, but like personally to committing to open source. I think that open source has made me a significantly better programmer, being able to, I think one of the most important skills that I've developed from my involvement in open source has been being able to look at other people's code and kind of figure out how it works, and just working through unfamiliar code and processes, which is not a trivial thing to learn, and is not something that I think that we as an industry have a good framework for teaching yet. So I think that one of the best ways to learn it is to get involved with open source. And I wish I had better advice for how to learn that skill otherwise, but that is kind of a learning by doing thing. And doing open source is a good way to get there.
Awesome. So I second the open source recommendation. I'll add one small recommendation of my own, which is, I think another thing that I figured out on this call that we have in common is we both have Lego sets built in our background. I really enjoy building Lego. I don't know which one is that. Is that like Ewoks, or is that a treehouse?
It's like a treehouse, I think. Yeah, I've been working on migrating it to fall.
Oh, nice. So yeah, I have a double-decker bus behind me. I really enjoy. Yeah. I enjoyed Lego when I was really like a young child. I have now rekindled that love. I really enjoy it. If you have a chance, you should definitely do it. There's something that I still can't explain about why it's so much fun. It's kind of like I don't know. So my wife says it's like IKEA, but more complicated, so better. So yeah, you have to like build stuff. I think it's a lot of fun, so you should totally do that. And yeah, that's it. David, thank you so much for joining this podcast. I'm sure everyone learned a ton, and this was really awesome. So yeah, thanks.
Yeah, it was a pleasure. Thank you for giving me an excuse to tell my life story. And just one last little follow up. My wife and I refer to IKEA as adult Legos. I just thought that was. Yeah.
So it goes both ways. That's great. Yeah. Awesome.
Well, thank you everyone for having me.
Yeah, thanks everyone for joining, and I'll see you next time. Bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.